natural satellite of Earth and also the closest celestial body to us in outer space. It orbits Earth at an average distance of 384,400 kilometers, about 30 times the diameter of Earth. The tidal force between Earth and the Moon has synchronized the Moon's orbital period. This causes the Moon's orbital period to exactly match its rotation period. Therefore, when viewed from Earth, we only see one side of the Moon, with the other side always facing away. For a long time, humans have wanted to conquer the Moon, with future plans to build bases for long-term settlement there. And of course, as human presence on the Moon increases, accurately calculating the Moon's time is inevitable. Recently, using Einstein's theory of general relativity, physicists discovered that clocks on the Moon run faster than clocks on Earth. This discovery will guide future lunar exploration missions. So, what is the truth behind this story? Let's explore together. What time is it on the Moon now? A seemingly simple question, but it's not easy to give an accurate answer. In April 2024, the White House issued a challenge to scientists, asking them to establish a time tracking standard for the Moon, aiming for increasing international presence there, and shaping future lunar bases. The question being answered is not what time it is on the Moon now, but rather how time passes on the Moon. Anyone can time or set the time with a clock. But physics determines how time flows. In the early 20th century, Albert Einstein determined that two observers would not agree on how long an hour is if they are not moving at the same speed in the same direction. This means the flow of time depends on speed, gravity, and position. Therefore, according to Einstein's theory of relativity, there is no such thing as absolute time. A clock on Earth runs slower than a clock in orbit due to the effects of gravity. That's why GPS satellites in orbit always had to account for relativity. They base on coordinated universal time and other standard times on Earth to calculate time most accurately. Returning to the US government's request to determine the precise flow of time on the Moon. The story seems quite simple, but it's not as easy as we imagine. Determining the exact flow of time on the Moon is extremely difficult due to the complexity of motion and gravity between Earth and the Moon. Rotation and the Moon. This means any lunar clock would have a different flow of time than clocks on Earth. Theoretical physicist Bijanath Paller of the U.S. National Institute of Standards and Technology in Colorado said that if we were on the Moon, clocks would run differently than on Earth. He noted that the Moon's motion relative to our motion causes clocks on the Moon to run slower than standard clocks on Earth. Gravity is lower than Earth. Therefore, if we place a clock on the Moon, it would be affected by two forces, one making it run slower, the other making it run faster than clocks on Earth. When scientists used Einstein's theory of relativity to calculate the precise time drift on the Moon, the result was a time drift of 56 microseconds per day, equivalent to 0.000056 seconds per day. This means clocks on the Moon would drift faster than clocks on Earth, specifically 0.000056 seconds faster per day. Scientists say that although the 56 microsecond difference per day is very small by human standards, it is crucial when scientists control spacecraft missions with high precision or maintain communication between Earth and the Moon. especially as the moon increasingly hosts international missions and is designated for building sustainable bases in the future. Sharon Gorhamling, a systems engineer at NASA's Goddard Space Flight Center, said that when it comes to navigation, a 56 microsecond drift per day between a clock on the moon and one on Earth is a significant difference, so you must adapt it. Currently, precise spacecraft positioning relies on time synchronization, including the use of radio waves transmitted at the speed of light. That is, in just 1 nanosecond, radio waves travel about 30 centimeters. Therefore, if time is not synchronized, a 56 microsecond discrepancy on the moon could lead to positioning errors of up to 17 kilometers per day. You see, time synchronization is extremely important. Otherwise, scientists cannot accurately determine where their spacecraft is in space. On July 21, 1969, a mysterious NASA device abbreviated as LRRR was deployed on the moon during the famous Apollo 11 mission. This device was designed to test Einstein's theory of general relativity on the moon and is essential for understanding the different speeds at which clocks run on the moon compared to Earth. The device consists of a series of quarter-cube reflectors mounted on a panel. Scientists use laser beams sent from Earth to shine on the device so it reflects them back. The response time of the signal can be used to measure the distance from the source to the device's location. However, immediately after deploying the device, scientists attempted to detect the response signal but failed due to limited observation time and inability to determine the device's exact location. Fortunately, later when using larger observatories, they finally captured the response signal, helping scientists achieve a breakthrough with precise distance measurement up to 15 meters. Strongly influenced by gravitational forces from Earth, the Sun, other planets, and even satellites in Earth. To conclude that clocks on the moon run 56 microseconds faster per day than on Earth, scientists had to calculate multiple gravitational forces affecting the moon to obtain relatively final results. It's coincidental that this figure exactly matches results from an independent study by scientists from the University of Missouri and the U.S. Naval Observatory, also yielding 56 microseconds per day. This excited many scientists and raised questions about whether this could be a standardized model for the moon. Of course, to standardize and unify a model, scientists need more than that. However, different studies producing identical results is a positive signal, helping them obtain more accurate and reliable figures. Now, you know how clocks on the moon run differently from those on Earth, right? Hopefully in the future, scientists will conduct more new research to help humanity better understand the moon, Earth's only natural satellite. At this point, this video will take a break. Wishing you relaxing and informative moments. Goodbye and see you in future videos. Best regards, farewell. Please subscribe to the Guy and Migo channel to not miss exciting videos.